All right, let's jump right in. Data hiding is basically the golden rule of object-oriented programming, right? But what if you actually need to safely break that rule to build better software? Well, today we're going to figure out exactly how to do that. In this explainer, we're unpacking your lecture material on two of the most powerful and honestly kind of dangerous tools in C++, friend functions and operator overloading.
Here is our agenda for today. 1. Friend functions and data hiding. 2. Coding friend functions in C++. 3. Friend classes and assignments. 4. Basics of operator overloading. 5. Advanced operators and restrictions. And finally, 6. Key takeaways and exam review.
Starting off with Section 1, Friend Functions and Data Hiding. Let's quickly establish the fundamental rule that we're about to completely bypass. So data hiding is the absolute core concept of OOP. Think of it as the security system of your code. It ensures that private and protected members are securely locked away from outside interference. Standard external functions, they simply cannot see or touch this data. It's totally off limits.
And this perfectly illustrates what happens when you try to access a private member normally. We've got a simple class named myClass with a private integer called member1. In the main function, we create an object and try to just assign the number 5 to that private member. The results, the compiler throws an immediate error. You hit an impenetrable wall.
But C++ gives us an authorized loophole. It's called the friend function. This is a special feature that deliberately breaks the data hiding rule to grant explicit access to that hidden private data, and it's incredibly versatile. A friend can be a standalone non-member function, it can be an entire class, or it can even be a specific member function of another class entirely.
Moving on to Section 2, Coding Friend Functions in C++. Let's look at how this actually builds out in C++ syntax. Notice the syntax we're using here. Inside our distance class, there's a private integer called meter. To grant access to a standalone function, we have to declare it right inside the class body using the friend keyword. You literally write friend int add5 distance. By doing this, the compiler now knows this specific function is officially on the VIP list.
Now, what's really fascinating here is the definition step. Look closely. The function add5 is defined outside the class scope. Because it's fundamentally a global or standalone function, we define it without specifying the class name at all. There is no distance : scope resolution operator happening here. Yet, and because it was declared a friend, it just reaches right in and modifies that private meter variable by writing d.meter plus equals 5.
Okay, if you want to ace your exams, you need to lock down these strict rules. You absolutely must declare it with the friend keyword in all classes where it needs access. You define it outside the class without the class name. But listen, here is the absolute most common exam mistake: forgetting how to call them. Friend functions are invoked just like normal, regular functions. You do not call them using an object. You simply write add5d.
Section 3, Friend Classes and Assignments. The crucial thing to remember is that this concept doesn't just apply to single functions. Let's scale this up to your actual assignments and see how entire classes can be friends. When two complex objects need deep, seamless integration, say an acute angle class and an obtuse angle class, that both need to share some independent area calculation, you can just declare an entire friend class. This opens up all private and protected data between the two. Now, speaking of these kinds of integrations, let's break down the specific logic you'll need for your programming tasks. For your assigned course task, you're assigning one course per call to a faculty object. Just follow this exact scaffold from your lecture notes. First, check the department of the calling object. If they are in computer science, assign a course code starting with C. If it's management science, use M. Electrical engineering, give them an E. And this is critical. You have to build in a verification step that prints a warning message if the total assigned credit hours go over 12.
As for the salary function assignment, you'll want to trace these explicit steps to calculate the overtime bonus correctly. Check if the faculty's working hours are exactly 36. If they are, easy, just display the current salary. But if the hours are greater than 36, you need to calculate the difference. Add 1,000 rupees for every single extra hour, and then output that updated salary. Keep this exact logic flow in mind when you sit down to code.
Section 4, Basics of Operator Overloading. So now that we know how to bypass access restrictions, how do we bend the standard behavior of math operators so they actually work with our custom objects? This brings us to a classic exam question, one you'll almost certainly see. When you write something like C3 equals C1 plus C2 using custom complex number objects, what is the compiler actually doing behind the scenes? Standard C++ doesn't inherently have a clue how to add two custom objects together.
Here is the translation. When you overload the plus operator as a member function, the left object, in this case C1, is actually the one invoking the function. The compiler literally translates C1 plus C2 into C1.operator plus C2. The right object, C2, just gets passed as a direct argument into that function. And what happens when we chain them together, like C4 equals C1 plus C2 plus C3? Tracing this execution path means the addition of C2 and C3 happens first. Then the result of C2 plus C3 is added to C1, and that final result gets stored in C4. So in this chain statement, the add function is being called exactly 2 times. Moving to Section 5, Advanced Operators and Restrictions. Let's dig into some specific edge cases and very strict restrictions that you need to be ready for. Pay super close attention here, because the difference in execution order between postfix and prefix increments is a classic trap for multiple choice questions. In a postfix operation, like y equals x plus plus, the program substitutes the current value first, and then the increment happens. So if x starts at 1, y gets assigned 1, and only after that does x become 2. Prefix, on the flip side, increments the value first and then substitutes it. You really have to know this difference cold. Now, while you can overload almost everything in C++, from plus and minus all the way to new and delete, you absolutely have to memorize this list of restrictions. The dot operator, the dot star operator, the scope resolution operator, and the conditional question mark colon operator strictly cannot be overloaded. No exceptions. If you see them on a test, immediately mark them as unoverloadable. Keep these programming patterns handy when you're writing your code. For operators like plus equals, you're actively updating the existing object, so your function should return star this as a reference. But for the unary negation operator, the minus sign used to make a value negative, you don't actually alter the original object. Instead, you create a brand new temporary object, invert its values, and return that temporary object. Finally, Section 6, Key Takeaways and Exam Review. We've covered a ton of complex ground today in this explainer, so let's wrap it up with a quick recap. Here is your final checklist. Data hiding is strictly bypassed using the friend keyword. Those friend functions, they act like global functions and are invoked entirely without an object. When dealing with operator overloading, a symbol between two objects always translates to the left object, calling the operator function and passing the right object in as an argument. Make sure you can easily trace the execution order of postfix versus prefix, and never, ever forget those 4 unoverloadable operators. So we've mastered rewriting how standard operators work for our custom classes. But what actually happens when entire derived classes need to rewrite and override full functions from their parents? Well, that sets the stage perfectly for our next topic on function overriding, which is going to give you the foundation to build even more dynamic polymorphic systems. Thanks for hanging out with me for this explainer, and happy coding.